Gear, my making. Dave, am I high?
Hello, welcome back to the S3-1200 sampler series. This is a video series where we are documenting the process of building a sampler that is similar to the EMU SP-1200. Now in this video, we're continuing our work on our DC power supply. There's a couple things that we're going to tackle in this video. First thing we're going to do a little soldering crash course because we need to connect our 2.1mm barrel jack to some breadboard jumpers, and then the breadboard jumpers will be connected to our breadboard power supply in order to test it. Then what we need to do is add a couple more capacitors to our DC power supply. It's going to help filter out some high frequency noise and make everything run really smooth. And then we're going to add an LED and a resistor, and this is going to allow us to see whether the power supply is actually on. And then finally, we're going to take some DC voltage measurements with our multimeter. So without any further ado, let's jump in and get working. Okay, sweet. This is all the stuff that we need to do our soldering today. We've got our breadboard jumpers, we've got our wire strippers, we have our DC barrel jack, we have our solder flux, we have our lead-free solder, and of course, our soldering iron. Little rundown on the soldering iron itself. The stuff on the right is for cleaning the tip of the iron when it's hot. So the sponge and the steel wool can be used to clean excess solder off of the solder tip. To adjust the temperature of the soldering iron, obviously you use the potentiometer right here. 1 is sort of the coolest setting, 8 being the hottest setting. So I usually set it about halfway or a little over halfway at like 4.5. For the tip of the iron for this project, I'm using about a medium-sized tip. Soldering irons come with a whole bunch of different sizes, and I find medium is the best for sort of soldering wires to connections and stuff. For those who don't know, for the beginners out there, when you first get your soldering iron, the tip is going to be brand new. And there's a lot of different methods that you can use to kind of maintain the integrity of the tip. So the way that I was taught was you gradually increase the temperature of the iron while adding solder directly to the tip of the iron. So to get started, power up the iron, let it sit for a few minutes while it heats up. Once it's heated up, I like to take the tip of the iron and I wipe it on the sponge, and you hear kind of like a sizzle kind of sound. And that indicates that the tip is super hot. So I don't know if you can hear that, but the tip is cleaned off now. Got all that oxidation off of the tip. Yeah, it's ready to go. First thing that I want to do to get this breadboard jumper ready to be soldered to the barrel jack, what I'm going to do is I'm actually going to cut off one end, this sort of like long section here, and this connector with my wire cutters. Okay. And then these two connections, we have to strip them. So like so, and this one as well. These two are now ready. One thing we need to realize is that there are actually 3 connections on this barrel jack. We want to be connected to that pin in the middle, and we want to be connected to the barrel on the outside. The pin in the middle is this connection here, so we need to be connected to there. And then we want to be connected on the outside of the barrel jack, which is this top connection here. So I'm going to take a little bit of flux, and I'm just going to put a little tiny bit on those connections. So I just dabbed them in there. You can kind of see what I did, okay? And then to make things easy, I'm gonna take this end of the breadboard jumper, the bare copper side of the breadboard jumper, and just dunk it. And I'll do the same thing with the brown one, like so, okay? All right, so first thing we're gonna do is we're gonna add some solder to these barrel jack connections. It's gonna make attaching the wires a lot easier. So all you do is you take your tip and you're gonna place it on the connection, hold it for a couple seconds, and add some solder. So first thing that'll happen is the flux is gonna melt, and then you'll see as I add the solder will melt on as well. So here we go. You can spread it around a little bit, like so. So that's the first one. And then we'll do the other one. This one here. Okay. So there we go. Now let's do the wires. And same thing over here. Okay. That one there. Cool. All right. Now, this is the tricky part. Take my iron and I'm going to place it on the pad, and the solder will heat up, and then I'll just place the wire on top like so. Okay, that's it. And then we'll do the other one. Here we go. We're all set. So now we have 2 breadboard connections on our jack. All right, we need a couple more parts for our power supply. I've got 3 0.33 microfarad electrolytic capacitors. These are going to go at the input of the voltage regulators. We've got a couple 0.1 microfarad film capacitors. These are going to be at the output of the voltage regulators. Then we've got 3 1K resistors that are going to be at the output as well with LEDs. Okay, here's the power supply from the last video. It's getting pretty crazy with the amount of wires and stuff already. So if you're building this at home and you're having trouble seeing what's going on in the video, I'm gonna post some detailed pictures on the Patreon as well as update the schematic. So you can check all that information out there. I'll do my best to make sure that you can see everything in the video, but if not, that's the place to go. Okay, so we're going to start off with our 0.33 microfarad capacitors on the positive voltage regulators, so the 12 volt regulator and the 5 volt regulator. We will take the positive lead and connect it to the input, so pin 1, and the negative lead to ground. Okay, so that's the first one. And then let's do the 5 volt regulator, which is this one over here. It's a little harder to see. And then the negative regulator, since it's negative, right? The negative lead of the capacitor is going to go to the input, so pin 2, and the positive lead is going to be connected to this red rail here, which is our positive rail. Then we're running out of space on the breadboard, so I'm going to use some breadboard jumpers and connect it to the output of each voltage regulator, and then connect it to a blank row. Okay, I'm going to do that for each of the regulators. Then negative 12 to here. Great. So next thing what we're going to do is we are going to take our 0.1 microfarad capacitor and go from the output here to ground on the 12 volt regulator. Same thing with the 5 volt. Okay. Then we'll do the same thing on the negative 12. Like so. Then we're going to take our 1K resistor, put it at the output, and then go to a new row on each of the regulators, okay? Perfect. Okay, so now let's take a look at our LED here. We've got a long lead and a short lead. The long lead is the anode of the LED. The short lead is the cathode. So the cathode goes to ground on our positive regulators, and the anode goes to the other end of the resistor. Go to ground, like so. Same with this one. Man, it's getting cluttered. Okay, there we go. And on the negative, we want the anode to go to our positive side, okay? So to our red side, and the cathode is connected to the other end of the resistor. Okay, looks pretty good. Now we need to do our power. So let's move this out of the way a sec. Here's our power supply. This is a 12 volt AC power supply at 1500 milliamps, okay? You want AC output. Make sure that you get an AC power supply. DC will ruin your weekend, okay? It has to be AC. Otherwise, this will not work and you will damage components. The other thing I want to mention is, and this is super important, we are dealing with things that are plugged into the wall. Please do not touch the circuit when it's plugged into the wall. I am not responsible for any damage to you or your property or anything else, okay? Now I'm going to plug this into the wall, okay? Now, here's our power supply back. Let's plug in our barrel jack, okay? I'm just going to take the blue lead and connect it to the anode of our diode here. So that'll be one rail. The other side, the brown on the barrel jack, is going to be connected like so, okay? So that's our connection. When we plug this in, what we should expect is that we're going to see all the LEDs light up, okay? So please double check your work before you plug in your breadboard, okay? It is super important that all the capacitors are oriented correctly. Otherwise, they will blow up. You could start a fire. You could really, really, really hurt yourself, okay? Please do not touch anything in the circuit when it's plugged into the wall, okay? So let's plug it in and we should see all these LEDs light up. Okay, we are good to go. Okay, so here's our multimeter. There's a whole bunch of different settings on the multimeter, but the one that we're going to be using today is we're going to be using voltage, okay? The flat line means DC and the curved line means AC, and you can select between the two. Turn on the multimeter and notice how it's on DC. That's what we want for our measurements. We've got two leads on the multimeter. We have our positive and we have our negative. The positive is plugged into the voltage terminal and the black is plugged into ground or common. Before we get started taking our voltage measurements, I just want to mention something, and that is that the current draw on this particular power supply is quite low at the moment. If I was trying to power something else, like an ESP32 off of this power supply, I would have to add heat sinks to each of the voltage regulators, okay? And the heat sinks, I provided links to them in my bill of materials on my Patreon. And they are little devices that you attach to the voltage regulators, and they dissipate heat as current increases. I'm going to be adding these to the design of the PCB, but for right now and for our testing right now, I'm just going to be testing with the LEDs, right? So I don't really need to worry about voltage regulators overheating. Let's get started. So first thing we're going to do is we're going to test the 5-volt regulator. And what we do is we take our positive lead, the red lead on our multimeter, and we hold it against the output of that voltage regulator, which is the resistor at this point, right? Then we'll take our negative lead and we'll place it at ground. And that gives us 5 volts. Let's do the same thing, but with our 12-volt regulator. So positive on the resistor lead, negative on ground, and we've got 12.06 volts. Perfect. And so now let's do the negative 12-volt regulator. So we're going to take our positive lead and put it at the output, just like before, and the negative at ground, and we should see negative 12 volts, and we're getting about negative 12.05 volts. The last thing I want to mention about this power supply, all of these capacitors are charged at the moment, right? So what that means is when I unplug from the AC wall adapter, you're gonna see the LEDs dim. And while they're dimming, do not touch the capacitors. So here they go. I've unplugged, and you'll see it takes a little while for them to power down. They actually maintain quite a bit, right? They're still quite illuminated. But as you can see, they are going down. And when they're fully off, that means those capacitors, those big capacitors, are fully discharged. So yeah, just be careful when you're unplugging and plugging in, and you should be good. All right, sweet. The power supply works. We've got plus 12 volts, we got minus 12 volts, and we got plus 5 volts. So this is great. We got all the power that we need for our S3-1200 sampler. Next video, we need to take this from the breadboard, and we need to make our power supply module that's going to be inside of our sampler, right? We're going to jump into KiCad, do a little PCB design, and then we're going to ship it away, have the PCB produced, get it back, solder it together, and then we'll have our completed power supply module. If this is something that interests you, I encourage you to sign up for the Patreon. It is free to sign up. You get all the documentation that you need to build the project with us. You can also join the conversation on our Discord server. We have some people there. They are making the sampler along with us, which is really cool. So join that if you'd like. I'm also on Instagram. I'm also on TikTok. If you want to DM me questions, that's cool too. Hit the subscribe button here too. And yeah, thanks for watching, and I'll see you in the next video.